In this video, I'm going to show you how you can use 2D images and convert them to Gaussian splats. This opens an amazing world of possibility, and we can process these in TouchDesigner and other software. The code package I'm going to show you to do this is called MLSharp. It's made by Apple and it will work on both Mac and PC computers. In today's tutorial, to access and run this package, we're going to use the terminal, command line, and GitHub to access the files, install, and run them on our computer. This video is specifically for Apple Silicon Macs, and I'll make another video on my Patreon showcasing how to install this on a PC using PyCharm. The first thing that we need to do is to clone this repository to our computer. To do this, what I'm going to do is copy this URL for the GitHub repository, and in my terminal, I want to go to the folder that I want to clone this repository to. I'm going to type ls, and this is going to list all of the directories in my root folder. I have already created one called MLSharp tutorial. I'm going to write cd, which is going to allow me to go inside a directory, and I'm looking at this MLSharp tutorial here, which is where I want to clone this repo to. So I'll start off, I'm just going to write ml, and I'm going to hit tab for autocomplete. I can do an ls just to check there's nothing in that folder, and that is all good. And now what we can do is write git clone, and then I'm going to copy that URL to that repository and press enter. Before we create a virtual environment to run this repository, I want to install a few tools. These are already on my system, so the install process is just going to confirm that these are there. On your system, it might take a little longer. The first thing that we want for a Mac is we want the Xcode command line tools. And to do this, I'm going to write xcode -select space -- install. We can see in this case, the command line tools are already installed, so that install process isn't needed. But in your case, if that hasn't been installed as of yet, it will run. The next thing I want to do is install CMake. To do this, I'm going to write brew install CMake, and that's going to run and install the most up-to-date version of CMake on your system. It's also important to have Homebrew installed to run brew commands, and you can do that from the Homebrew website, brew.sh, and you can use this line of code to run in your terminal, and that will install Homebrew for you, and then you can run brew commands. Now we have these prerequisites installed, I can now make myself an environment. If we scroll down on the MLSharp page, we'll see some instructions to get started with this. So we can create a virtual environment in Python 3.13. Let's copy that and run the command. Conda is going to do its thing. You can press Y to allow it to install these packages. And it gives us handy information on how we can activate that environment. So I'm going to write conda activate sharp, run that. We can now see that my environment has changed to sharp. And now I'm going to install the requirements, pip install -r requirements, and obviously spell this correctly. You can also just copy this .txt and run that. Aha, so before running that install, we want to actually go inside our MLSharp folder, which we've downloaded. We had created an MLSharp tutorial folder, but now we want to be inside MLSharp. So cd into that folder. We can now see if I do ls, we have all of these files, including the requirements.txt. A handy trick that you can do when you're working in terminal is if I use the up and down arrows, I can go through previous commands that I have run. And in this case, we can go back to pip install r requirements.txt and run that. This is going to install any libraries that you need into the project. Amazing, that looks like the install has been successful. What we can do now as a check to see if this has installed correctly and that we can actually access this sharp code base is I'm going to type sharp -- help to interface with the help file of the project. That took a minute, but what this is showing us is this has installed successfully and that we can predict and render. Render won't work on my M1 Mac because that is tuned for NVIDIA GPUs, but we can predict using the M1 Silicon really well. The next step is we want to create a folder of images that we want to run this process on, and then we can run the path that gives the input and out directions through predict. I'm just going to create a folder right now. I'm going to open the repository that I'm in. We can see all this stuff that has been created. I'm going to make a folder called in ims and a folder called out ims, or actually this should be out splats. And let's find a few files to run through this. And I'm going to bring in some images that I've already selected for another project. These are images that I took recently on a trip to Tokyo where I was performing at Mutech, and they come out really well through this MLSharp method. What we can do now is write in sharp predict -i, and then we're going to bring in the path to our input images and output images. And so what we're going to do is just move out one layer. I'm going to drag in this. So the -i signifies that's an input. Then we're going to do -o, which signifies an output. And this is where we will drag the directory that will populate for our outputs. And now this has been populated, we can run by pressing enter, and we should generate our splats. The first time you run this, it may download some extra information. And let's see what happens as we run this process. You can see it's running. And here we have our first PLY output. And we'll do this fairly quickly for all of the splats. While that's running, I'm going to open TouchDesigner. Delete the opening scene, and I'm going to bring in my Gaussian Splat viewer. This is available on my Patreon, so go ahead and download that. It is currently available for free. I'm going to go inside this base, and on the geo for Gaussian Splat Pop, I can just drag in to the PLY field, whichever PLY I want to visualize. And there we go. What we will see, if I actually split my screen and make a panel, because we can then control this, is that this has now populated really nicely. Just going to make a few changes really quickly. Parent parameters on panel, we want to do middle and right. So now we can zoom in and actually navigate around. It is also handy in the camera viewport to enable the keyboard. And then you can move around with the W, A, S, and D keys. I'm going to speed it up a little bit. The walk and the turn faster. Don't get motion sick doing this. If you press Q, oh yeah, definitely turn down that turn to like back to 3, which is the default. If you press Q and E, you're going to pan around. So this gives you a really cool scene that you can work with. Let's load in another one. And you can see that is super cool and realistic just from a 2D photo. What you can do to make sure this always loads in a central position is if we go inside the Gaussian Splat pop, might take a second, and I'm going to create a new transform after this switch. I'll plug it into this transform too. And on the Align tab, I'm going to do Origin Center for all of these. So now when I press H, and we are splat bang in the middle of the splat. In this case, we might want to also just affect that orientation. Minus 180, just to make sure. Let's try loading in another splat. Press H. And now, again, we're not necessarily super inside the splat, but we're accessing it pretty well. And let's see here, we have a Hello Kitty sign in a department store. And this is a super cool effect. It does always require a little bit of adjustment as you bring in these splats, as they're all kind of different sizes and in different world spaces. But you can, with a little bit of work, tweak them and visualize them in the center of your screen really, really nicely. You have all the old controls that you had before for Gaussian Splats. So you have the splat size, so you can bring that up and down. You have the alpha threshold, so you can control the opacity on that and that sort of nice diffused edge. And you can also play around with the uniform scale. Delete range, if you have really big splats that you want to work with, will control the center point. And with these values here, you can control the center X, Y, and Z. More useful for bigger world splats, but still quite useful for editing these. And yeah, I hope this technique is useful. It's another way of expanding the universe of what we can do with Gaussian splats and with just using still images to create very realistic scenes. Another tool that is extremely useful for editing your splats and getting them ready to load in is a website called SuperSplat. If you type in SuperSplat, you can go to the SuperSplat editor and you can drag in a splat. You're going to see where in space it is. And then what you can do is you can align that with the center of your scene. You can select bits, crop them out. I'm not going to give a tutorial on that today, but this is a really useful tool for just selecting and moving your scene around. When I'm done, I can go to File, and then I can export it as a .ply, and then that will be imported into TouchDesigner as well. And of course, when you bring it into TouchDesigner, you can go inside the comp, and you can add in different edits as well. So for example, we can make it really noisy. And because these are big world space files, we have to really bring this up. But there we go. We can make it noisy. Let's take that down a little bit. And then animate. And let's, again, period up. So there we go. We're really warping reality here. And the frame rate's really high, and my computer is really low on battery, so this is great. It's running super fast. If we bring up the splat size a little bit, things even start getting a bit more realistic. Or if you bring it down, you get that nice point cloud aesthetic that we know and love. Thanks for watching. Stay tuned. I'll be posting lots more tutorials and methods of how to do cool stuff in TouchDesigner and other tools in 2026.